Here we have example 9. Okay. Now example 9 here, I have given you the diagrams. Now that this is the questions. A line shaft is driven by means of a motor placed vertically below it. So below this motor pulley here, or below this pulley here, you have another pulley. That is the motor pulley, which is placed below this line shaft here. Now the pulley on the line shaft is 1.5 meter in diameter. So this diameter here is 1.5 meter and has a belt tensions of 5.4 kilonewton and 1.8 kilonewton. So we have the maximum tension, tight side tension 5.4, and then the slack side tension of 1.8 kilonewton. Okay, now both these tensions may be assumed to be vertical. So vertical, so the angle of lap, okay, in this case, but then we don't need the angle of lap, so it's 180 degree actually. Now both these tensions may be assumed to be vertical. Now if the pulley is to be overhang from the shaft, that means you have what you have here, that means we can consider this as a cantilever. The distance of the center of the line of the pulley from the center line of the bearing being 400 millimeter. So from the center here to the center of the bearing, this is 400 millimeter. Okay, so find the diameter of the shaft assuming a maximum allowable shear stress of 42 megapascal. So first thing, tight side tensions given 5.4 kilonewton, that is 5,400 newton. The slack side tension, which is 1,800 newton or 1.8 kilonewton. So the torque, so based on this, when you refer to this, the belt tension T1 and the belt tension T2. So this belt tension, these forces here, they are actually being tangent to the circumference of the pulley. So we can call this as the tangential force. So if let's say for example you take T1 here, multiply by the radius, is you actually got a turning moment in the anti-clockwise direction based on T1. And then if let's say for example when you refer to T2, that is 1,800 newton, multiply by this length, you actually got another turning moment that is going in the clockwise direction. So both the anti and the clockwise direction. That is why you have to minus T1, taking T1 minus T2, then the radius is actually common for both the case. So multiply by R, so you get the torque, the turning moment. So from here, you have the torque of 2,700 Newton meter. And remember, this is the radius, not the diameter. So you have to take this divided by 2, so you got 75 mm. Sorry, 750 mm or 0.75 meter. So the total vertical load S when you refer from the side, okay, the side view of the pulley, actually T1 and T2 are both forces that is acting vertically downwards here. So based on T1 and T2, okay, you get the total weight that is acting on the pulley. So the total vertical load that is acting on the pulley when you refer from the side, so you have to take T1 plus T2, so that is equals to 7,200 Newton. So this 7,200 Newton that is acting here on the pulley, multiplied by this length that is 0.4 meter, actually will give you a bending moment about this line here or about the bearing. So therefore, the moment is W times L. So the W, the total load, multiplied by the length 0.4 meter, so you will get the bending moment of 2880 Newton meter. So now in this case, we have both the bending and the twisting moment. So, and the questions have given us the shear stress. So the TE would be equals to, same thing, square root of m square plus t square. Put in your moment and the torque. So you have TE of 3947 Newton meter. So once you have found TE, then you can proceed with finding the diameter of the shaft. So this is the diameter. Shear stress is given 42 megapascal, and we have found out the TE is 3947. So 42 megapascal. So you would be able to find out the diameter of the shaft for such condition as 78 millimeter, or you can round this up, or you can bring it to 80 millimeter, but not less than 78. It must be larger than 78. So that's the answer for the diameter of the shaft. So that's the end of the example 9, and we will continue with example 10 shortly. So thank you. If you have any comment, please put your comments on the comment section of my YouTube channel under Design of Shaft. Thank you very much for watching my podcast. Okay, see you all later or next time. Thank you very much. Bye bye.